In this module, you will be in a position to understand the following. Number 1, review the basic statistical concepts that are basis of psychometric theory and principles. Number 2, understand frequency distribution and measures of standard tendency and variabilities. Number 3, understand normal curve and diversion from normality. And finally, number 4, define and differentiate among various types of standard scores. One of the primary roles of a psychometrician is that of a test taker. Psychometricians design tests and use them in different settings like business, academics, clinics, counseling, so on. Measurement of individual performance by means of psychological tests is normally expressed as scores. Test scores are frequently expressed as numbers, and statistical tools are used to draw inferences and conclusions about these numbers. Data collected from tests and experiments may have the significance to a psychometrician until he knows the art of arranging and classifying scores in some meaningful way. The primary task, therefore, is to classify and organize the test scores by applying the knowledge and skills. Statistics is the science of classifying, organizing, and analyzing the data. Without statistical tools, a psychometrician is in a fix to comprehend the meaning of test scores and results of a carefully controlled experiment. Thus, it will be useful to freshen up on some statistical basis so that advanced statistical computations used in psychological assessment can be understood in a meaningful and better way. In this module, we will review frequency distribution, measure of standard tendencies, measure of variability, characteristics of a normal distributed curve, skewness, kurtosis, p-values, and statistical significance. Finally, linear conversion of raw scores into standardized scores used extensively in measurement literature is also discussed, which generally we call it as a transformation of scores from raw scores to standard scores.
A distribution is defined as a set of test scores arranged for recording or study. A distribution helps to compare the performance of one with the others. One way by which scores can be distributed is by the frequency with which they occur. A frequency distribution groups scores under subheads or into classes according to defined rules. In a frequency distribution, scores are tabulated together with the number of times each score occurred. A grouped frequency distribution is another kind of frequency distribution in which class intervals are used to represent the actual test scores. The total number of class intervals and width of each class interval depends on the convenience and choice of statistician. However, commonly used grouping intervals are 3, 5 and 10 units in length, as they are somewhat easier to work with in later calculations. In a grouped frequency distribution, the higher and the lower class intervals are termed as the upper and lower limits of the distribution respectively. Let's do an example to understand. Depicted are the marks obtained by a class consisting of 30 students in their psychology midterm exam. If the question is to tabulate the raw scores into frequency distribution and grouped frequency distribution of class interval 3 and class interval 5, let's do the statistical computations. The first table depicts an ungrouped frequency distribution in which scores are written on the extreme left followed by their frequency in the next column. The second and third table represents grouped frequency distribution. The second table is a grouped frequency distribution in which the class interval is 3. Thus, the class intervals are 77 to 79, 80 to 82, 83 to 85 and so on. The third table depicts grouped frequency distribution with a class interval of 5. In this, class intervals are represented as 77 to 81, 82 to 86, 87 to 91 and so on. After discussing grouped and ungrouped frequency distribution, let's now study measures of central tendency. Central tendency is a statistical tool that measures the average or central position score between the extreme scores in a distribution. It gives a concise description of the performance of a group as a whole and helps an experimenter or a researcher to compare two or more groups in terms of a typical performance. The three most commonly used measures of central tendency are arithmetic mean, median and mode. Arithmetic mean or average represents sum of total scores in a distribution divided by total number of scores. Mean is considered as a balance point of the distribution about which the negative deviation equals that of the positive deviations. Mean is highly sensitive to the presence or absence of extreme scores in a distribution. The next measure of central tendency, which is median and also termed as the middle score of the distribution, divides the score in a distribution into exact two halves, the lower half and the upper half. Median is responsive to the number of scores above or below it, but not to their magnitude, and thus it is less affected by extreme scores than the mean. When the total number of scores ordered is an odd number, median represents the exact middle point with one half of the remaining scores lying above it and the other half of the remaining scores lying below it. If the total number of scores ordered is an even number, the median is the average of the two middle scores. The third measure of central tendency, which is mode, is generally used with qualitative data having characteristics of nominal scale. Mode is the most frequently occurring score in a distribution of scores. Though easy to compute, mode is subject to vary from sample to sample. In addition, a frequency distribution may have more than one mode for a particular set of scores. Let's see an example to understand the central tendency better. Given are the following scores to which mean, median and mode have to be computed. The mean can be calculated by adding all the scores divided by total number of observations, which is 7. Thus, mean value in a given score of distribution is 8.86. In order to find the median, order the scores in ascending order. The median is the middle value, which is 8, as it divides the score into exactly two equal halves. From the same list, if we have to calculate mode, we can see that 7 is the only score that occurs more than once. Thus, mode in this example is 7. After understanding central tendency, let's now study measures of variability. To define a distribution, we must provide a measure of variability along with the measure of central tendency. Measures of variability determine how scores in a distribution are scattered or clustered. Two or more distribution of scores can have the same mean with the difference in the scatter or dispersion of separate scores around their central tendency. Four measures through which variability is computed are range, interquartile and semi-interquartile deviation, variance or the average deviation, and the standard deviation. Let's understand the measures of variability one by one. The range is the most common measure of variability that compares two or more groups. It can be calculated by finding the difference between the highest and the lowest score in a distribution. Easy to calculate, the range is generally used as a rough measure and of little significance in inferential statistics. The interquartile range, represented by capital Q, is the difference between 75th, that is Q3, and 25th Q1 quartile points in a distribution. The semi-interquartile range is one half of the interquartile range. Both interquartile range and semi-interquartile range closely corresponds to the median in its characteristics and properties. The third measure, that is the average deviation or variance, is the mean of the deviation of all of the individual scores in a series taken from their mean. Average deviation is calculated by ignoring the positive or negative signs and treating all deviation scores as positive. Deviation scores thus calculated are added and then divided by total number of scores. Variance is widely used statistical tool of measure of variability because it is resistant to sampling variation. The last measure of variability, the standard deviation, is the most widely used measure in statistical sciences. It is the square root of the variance and used in both descriptive as well as inferential statistics. Comparing means of two distributions becomes simple and meaningful when standard deviation is used as a measure of variability. Let's do an exercise to understand. Given are the scores obtained by 8 students in their psychology class. Let's calculate standard deviation of the score. To calculate the standard deviation, first we need to have mean of the given scores, which is sum of all the scores divided by total number of observations. The mean becomes 9.5. Next, deviation score is calculated by subtracting each raw score with the mean, which is depicted in the second column of the given table. In the third column, square of each deviation score is done, which is followed by adding them in the next step to calculate standard deviation. As you can see, the deviation score sum comes to the value of 0. This is the reason why we square the deviation score. The value becomes 32 as can be seen in the column 3. Finally, to obtain standard deviation, we divide 32 by n minus 1, which is 7, and take the square root of the figure. We get the value of standard deviation in this case to be 2.14. After studying frequency distribution, central tendency and variability, the next comes in line the normal curve. Scores obtained on psychological tests are often said to be normally distributed in a population. The normal curve or the normal distribution curve is a bell-shaped, smooth, symmetrical, unimodal, continuous curve that peaks at the center, and as one moves towards the tails of the distribution, the curve tapers on both the sides. The tails of a normal curve are symptotic to horizontal axis, so that the area under the curve is maximum in the center and becomes less and less on both the sides. Being symmetrical with both the sides exactly replica of each other, the mean, the median and the mode of a normal distributed curve has same value. As you can see in the given figure that the mean, the median and the mode of a normal distributed curve have same value. Seeing the curve, let's now identify the characteristics of normal curve. As you can see, 50% of the scores occur above the mean and 50% of the scores lie below the mean in a normal curve. Further, about 34% of all the scores occurs between the mean and one standard deviation above the mean. About 34% of all score lie between the mean and one standard deviation below the mean. About 68% of the total scores lie between the mean and plus minus one standard deviation. About 95% of the total scores occur between the mean and plus minus 2 standard deviations. About 99.7% of the total scores occur between mean and plus minus 3 standard deviations. Students, I hope that you have now understood the characteristics and the properties of the normal curve. What happens when a curve is not a normal probability bell-shaped curve? That is, it is either skewed or it shows the property of kurtosis. A frequency distribution can be defined depending on the nature and extent to which symmetry is present or absent. If the distribution looks similar on the left and right side of the center point, it is called a normal distribution curve or a symmetrical curve, what we have discussed just now. In a symmetrical distribution, the values of mean, median and mode are equal. In contrast, lack of symmetry in a distribution makes it skewed, in which the mean and the median fall at the different points in the distribution and the center or the balance point is shifted to either the left or the right side. The presence of relatively extreme scores at the high end of the distribution makes it positively skewed. In a positively skewed distribution, the mean, the median and the mode relationship is represented as mean is greater than median and greater than mode. A distribution is said to be skewed negatively when extreme scores are present at the low end of the distribution. The relationship is then expressed as mean is less than median, median is less than mode. After discussing skewness, now let's see what is kurtosis. Kurtosis corresponds to the shape of a frequency distribution as compared with the normal. It describes whether the distribution is peaked or flattened. The three general types of the curves on the basis of their shape are leptokurtic, which is a frequency distribution more peaked than the normal. Second is platykurtic, which is a relatively flatter curve than the normal curve. And third is mesokurtic, which is a normal flat curve. The concepts most widely used in behavioral sciences. Consider an example in which a researcher is interested to test the hypothesis that girls exhibit more shy behavior than boys. To answer the question and carry out an empirical investigation, researcher decided to collect the data. A sample of high school students comprising of equal number of boys and girls was selected and subjected to a questionnaire rating the level of shyness. Suppose 70% of the responses agreed with the fact that girls are shyer than the boys, and the remaining 30% disagreed. Would it be justifiable to conclude that girls exhibit more shy and bashful behavior than boys? What would have researcher concluded that if he would have got responses in the ratio of 55% agreement to 45% disagreement? What if the percentages were 65% to 35%? This signifies that there should be a criterion with which the researcher can claim that a statistically significant difference exists between girls and boys on their level of shyness. This criterion is commonly known as alpha level of significance. It reports that the difference found between the groups in a sample would happen by chance alone x number of times out of 100. Usually x equals to 1 or 5, which means that the difference in percentages found in the sample would have to be large enough to only occur by chance 1 out of 100 times. Alpha in this case would be 0.01 or 5 out of 100 times, in which alpha will become 0.05. Although the level of significance should be decided upon before any data collection, many researchers fail to report the alpha level of significance and instead report only the p-values, which is the probability level of the sample outcome if null hypothesis is true. Suppose a p-value for a particular statistical test is equal to 0.06. Then this means that results from the particular sample would occur by chance alone 6 times out of 100. Consider if the p-value equals to 0.50. Then this can be interpreted that the results from the particular sample would occur by chance alone 50 times out of 100. Similarly, a p-value of 0.007 means that results from the particular sample would occur by chance alone 7 times out of 1000. Students, in psychological sciences, research workers generally make decisions and evaluate the outcome of the test according to 0.05 and 0.01 levels of significance. Psychological measures have meaningful interpretations of raw score only when they are converted from one scale to another. The latter typically being one that is more widely used and interpretable, that has some arbitrarily defined mean and standard deviation. Raw scores in them carry no meaning unless and until they are converted to standard score. What is this standard score? A standard score provides meaning by relating the position of a raw score to other score in the same distribution or to a distribution of scores by a representative group. With standard scores, the relative position of a test taker's performance with other test takers can be known. Standard scores are obtained by linear transformation of raw scores, and therefore they have a fixed mean and standard deviation. The proportionality of the inter-score distances in a distribution remains constant in the process of derivation of standard scores from raw scores. While we will be enumerating many types of standard scores, the concept will further get clear. Standard scores derived from raw scores involve two types of transformations: linear transformations and nonlinear transformations. A linear transformation of raw score preserves the proportionality of inter-score distance and thus the shape of the distribution. the magnitude of differences between standard scores exactly parallels the differences between corresponding raw scores. Z-scores and T-scores are examples of linear transformation of scores. A non-linear transformation of data is required when the raw score are not normally distributed and comparisons with normal distribution need to be made. When such a non-linear transformation is done, the original distribution is said to have been normalized. Conceptually, normalizing a distribution involves stretching the skewed curve into a shape of a normal curve and creating a corresponding scale of standard scores, a scale which is technically referred to as normalized standard score scale. Percentile rank and Stenine scores are examples of normalized standard score scales. Let's detail linear and non-linear transformation of scores in a greater detail. The first in this list is Z-score. The most commonly used type of standard score is a Z-score. It represents how many standard deviation a raw score falls above or below the mean of the distribution. The mean and standard deviation of a set of Z-scores are 0 and 1 respectively. Mathematically, Z-score is represented as x1 minus m upon sd, where x1 represents raw score, m is the mean of the distribution and sd is the standard deviation of the distribution. Let's do an example to understand Z-score. Consider a distribution of a set of test score having a mean of 80 and standard deviation of 10. For the given distribution, a raw score of 92 will equal to the standard score of 1.2, as Z in this case would be equal to 92 minus 80 upon 10, which comes out to be 1.2. What are the properties of Z-score? The mean of a set of Z-score is always 0. The standard deviation of a set of standardized score is always 1. The distribution of a set of standardized score has the same curve as the unstandardized scores. Last, scores on a Z distribution can have both positive as well as negative values. Next in the list of standard score is the T-score. It is a standardized score that has the mean of 50 and standard deviation of 10. The scale used in the computation of T-scores is called a 50 plus or minus 10 scale, represented as T is equal to 10Z plus 50. In the above example, the equivalent T-score can be calculated by applying the formula 10Z plus 50, which is equal to 62. The fact that a T-score can never have a negative value gives it an advantage over Z-score. It is to be noted that a widely used personality test, Minnesota Multiphasic Personality Inventory (MMPI), uses T-scores as standardized measure. The third one is the Stenine score. Stenine score is a standard score with a mean of 5 and a standard deviation of approximately 2. The word Stenine is derived from two contractions, namely standard and 9. Thus, it is a standard score divided into 9 units. Stenines, widely used in educational assessments, have a whole number value ranging from 1 to 9. The main advantage of Stenine scores is their simplicity, as just one digit is required to express the Stenine's value. But remember, Stenine is a coarse unit of measurement because the differences between successive Stenine values is 1/2 of a standard deviation. The last in the list to understand is percentile rank. It represents a type of derived scores that describes the location of a raw score in relation to the other scores in a distribution. It has an advantage in terms of directness of meaning. A percentile rank of 68 on a psychology test means that a student performed better than 68% of comparable students in the class. Percentile ranks are easy to comprehend and is relatively meaningful even to persons without statistical training. What we have studied in the module. We studied that statistical tools are the basis with which psychological test scores are made interpretive. Statistical data deals with large number of observations. To comprehend the meaning of these large number of responses, frequency distribution is arranged, which shows the number of observations for the possible categories or scores values in a set of data. To describe a frequency distribution adequately, we must provide a measure of central tendency as well as information about its variability and shape. Central tendency is calculated using mean, median and mode. Variability is represented by range, average deviation, interquartile range and standard deviation. Further, the normal curve is a smooth, bell-shaped curve which is symmetrical, continuous with two tails asymptotic to horizontal axis. Divergence from normalcy is determined by skewness and kurtosis. We also discussed about the standard score, which is a derived score from a given raw score whose meaning and interpretation becomes possible after derivation. Different types of systems for standard scores exist, each unique as regards to its mean and standard deviation. The four types we discussed in this module were Z-score, T-score, stenines and percentile ranks. Student, always remember that the knowledge of basics of statistics is essential for a psychometrician to communicate the meaning of data. One of the primary roles of a psychometrician is that of a test taker. Psychometricians design tests and use them in different settings like business, academics, clinics, counseling, etc. Their task, therefore, is to classify and organize the test scores by applying proper statistical tools. A distribution can be defined as a set of test scores arranged for recording or study. A distribution helps to compare the performance of one with the others. A frequency distribution groups scores under subheads or into classes according to defined rules. In a frequency distribution, scores are tabulated together with the number of times each score occurred. A grouped frequency distribution is another kind of frequency distribution in which class intervals are used to represent the actual test scores. Central tendency is a statistical tool that measures the average or central position score between the extreme scores in a distribution. The three most commonly used measures of central tendency are arithmetic mean, median, and mode. Now let us see how the mean, median, and mode are calculated. Firstly, arithmetic mean or average represents sum of total scores in a distribution divided by total number of scores. Secondly, the median, also termed as middle score of the distribution, divides the score in a distribution into exact two halves, the lower half and the upper half. Finally, the mode is the most frequently occurring score in a distribution of scores. Measures of variability determine how scores in a distribution are scattered or clustered. Four measures of variability are the range, the interquartile and semi-interquartile deviation, variance or the average deviation, and the standard deviation. The range is the most common measure of variability that compares two or more groups. It can be calculated by finding the difference between the highest and the lowest score in a distribution. The interquartile range, represented by Q, is the difference between the 75th and 25th quartile points in a distribution. The semi-interquartile range is one half of the interquartile range. The average deviation or variance is the mean of the deviations of all of the individual scores in a series taken from their mean. Finally, the standard deviation is the square root of the variance and is most widely used variability measure in descriptive and inferential statistics. Scores obtained on psychological tests are often said to be normally distributed in a population. The normal distribution is a bell-shaped, smooth, symmetrical, unimodal, continuous curve that peaks at the center, and as one moves towards the tails of the distribution, the curve tapers on both the sides. In a normal distribution curve, about 68% of the total scores lie between plus minus 1 standard deviation. About 95% of the total scores occur between plus minus 2 standard deviation. About 99.7% of the total scores occur between plus minus 3 standard deviation. Divergence from normality occurs in two forms. First is skewness. It represents lack of symmetry in a distribution. The presence of relatively extreme scores at the high end of the distribution makes it positively skewed. A distribution is said to be skewed negatively when extreme scores are present at the low end of the distribution. The second divergence is kurtosis. It is described as whether the distribution is peaked or flattened. The three general types of the curves on the basis of their shape are leptokurtic, a frequency distribution more peaked than the normal; platykurtic, a relatively flatter curve than normal curve; and mesokurtic, a normal flat curve. Divergence from normality occurs in two forms. First is skewness. It represents lack of symmetry in a distribution. The presence of relatively extreme scores at the high end of the distribution makes it positively skewed. A distribution is said to be skewed negatively when extreme scores are present at the low end of the distribution. The second divergence is kurtosis. It is described as whether the distribution is peaked or flattened. The three general types of the curves on the basis of their shape are leptokurtic, a frequency distribution more peaked than the normal; platykurtic, a relatively flatter curve than normal curve; and mesokurtic, a normal flat curve. The other two statistical concepts of measurement are p-value and alpha level of significance. P-value. It is the probability level of the sample outcome if null hypothesis is true. If the p-value equals to 0.50, then this can be interpreted that the results from the particular sample would occur by chance alone 50 times out of 100. Alpha level of significance. It is the criterion with which a researcher can claim that a statistically significant difference exists between the groups or samples under study. In psychological sciences, research workers generally make decisions and evaluate the outcome of the tests according to 0.05 and 0.01 level of significance. A standard score provides meaning by relating the position of a raw score to other scores in the same distribution or to a distribution of scores by a representative group. One of the most common type of standard score is Z-score. Z-score represents how many standard deviation a raw score falls above or below the mean of the distribution. Standard scores derived from raw scores may involve linear or non-linear transformations. A linear transformation of raw scores preserves the proportionality of interscore distance and thus the shape of the distribution. A non-linear transformation of data is required when the raw scores are not normally distributed and comparisons with normal distribution need to be made. Let us now summarize what we have learnt in this module. Statistical tools are the basis with which psychological test scores are made interpretive. To describe a frequency distribution adequately, we must provide a measure of central tendency. The normal curve is a smooth, bell-shaped curve which is symmetrical, continuous, with two tails asymptotic to horizontal axis. The knowledge of basics of statistics is essential for a psychometrician to communicate the meaning of data.